Now, the next part I want us to talk about is triangles. And eventually you're going to see how triangles comes into it. So do you remember the different types of a triangle? We have the scaling triangle. We have isosceles triangle. And then we have the equilateral triangle. Now, the scaling triangle, equilateral triangle, not applicable. This time I want to highlight the isosceles triangle, all right? Now, what makes an isosceles triangle? An isosceles triangle is one that has two lines that are equal in length and the other one that is different. So these two lines are usually equal to each other. But this line here is not the same as the length of these other two lines. Now that's the first property of an isosceles triangle. Now the next property, which is very important, is that at the base of those two lines that are equal, they also have angles that are equal to each other. So once you have these two lines here, which makes an isosceles triangle, then the base angles must be equal. So if you remember very well, in your secondary school days, you were taught that the base angles of an isosceles triangle are always equal. Of course, a scaling triangle has all the sides. None of them are equal to each other. The equilateral triangle has all sides equal and all angles equal. But the focus here is an isosceles triangle. Now, how could you get an isosceles triangle from a circle? It's easy, because you could be given questions where you have a circle and then you have a radius, which comes from here to here, and another from here to here. And then you have a chord that actually makes up the triangle with those two radii. You see, this is a radius, and then this is a chord. Automatically, you already have an isosceles triangle. So knowledge of an isosceles triangle is essential for circle theorem, all right? We are going to see where to use it. I just want you to have all of this in mind.